All right, folks, welcome once again. Okay, so we are in day 9, right? We are in day 9, and today we'll be starting and finishing module 6, right? So we'll be on schedule with our agenda if we are able to finish module 6 today. And today we'll be talking about high availability, scalability, and fault tolerance using the elastic load balancer and also the auto scaling group. Okay, this is the agenda. Now, all right, so this is where we are in the course. So we have finished the basic services, right? The core services, EC2, S3, VPC, and RDS, right? So these are some of the core services, stuff that you'll be using on a day-to-day basis, right? The most important things, the services that most people use most commonly. Right, so we've finished that. Now you're in a good position to sort of set up your applications, try out some proof of concept, set up some test environments, maybe, right? So we have done all that, and now from this module onwards, we'll turn our attention to live environments or production environments. Okay, so far, we're looking at building blocks, basic building blocks, right? So it's good for test environments, maybe some smaller live environments as well. But from now onwards, module 6 onwards, we'll look at live environments and production environments, right? And the services that are important for such environments. So today. Is an important topic because we're talking about high availability, scalability, and fault tolerance, and this is a very important part of a solutions architect's job. Okay, because these things have become a basic thing. These have become hygiene factors, which means all applications need to have these, need to be highly available, need to perform well at all times, right? So this has happened because the world has become used to things like Facebook, Google, and these guys have done a very good job, right? They have the infrastructure and the automation and the high availability and the fault tolerance. Their platforms are built in such a way that they are always up, right? So these applications are always up, they're always fast, right? And most of the people in the world, have become used to that, and that's why the expectations are the same from your applications as well. Right. So, like I said before, in a competitive market, if your application is down for some time, right? Even if it happens once a year, that'll be very negative, right? That'll be very negative for your brand, and you may not be able to compete. You may not be able to. Your customers may not come back, right? So. And even in the enterprise world, right? What used to happen before is internal applications. Lots of companies have internal applications, and the internal applications were never as good as some of the commercial products, but the employees were not really exposed, right? The people were not really exposed to services like Facebook and Gmail before, right? So you could get away with low quality or low, uptime type of applications before, but now the expectations of from internal applications are also very high. Okay, so in that sense, this topic is very important. All right. So now, the way we will achieve high availability and fault tolerance and scalability is actually very simple. Okay, it's very simple. With AWS, you have a couple of features that we'll talk about. This is the load balancer and then the auto scaling group, right? And then on the database side, RDS has the multi-AZ deployment, which we spoke about yesterday, right? So if you combine all these, the load balancer, the auto scaling group, and the RDS multi-AZ deployment option, you can create in a very simple manner a highly available site, and also a highly scalable application. Okay, so this could be a web application or a mobile applications backend, right? So it's very easy to do it, and that's what our topic is today. Okay, so let's do a quick review of the previous module, right? Let's do a quick review. This was databases, and we spoke about 4 database services, right? And all 4 are sort of complementary. they're complementary services. It's possible for you to include multiple services, maybe 2 or 3 or even 4 in your stacks, right? And the reason you can do it is because on the cloud, it's very simple to set up these services. You can set up RDS instances, maybe Elasticache instances in a very simple manner. And more importantly, the maintenance is very simple as well, right? So you don't need the same level of effort, the same level of expertise that you would need outside of the cloud, right? And because of that, it's possible for you to use these services, multiple services in your stacks. Okay, so that's a very big change actually. If you think about it, it's a very big change. And now when you design new applications, you can think of using multiple database technologies in the same application, right? And like I mentioned yesterday, even when you migrate existing applications, right? The recommendation is to migrate as is, but once you migrate, you can sort of leverage the cloud capabilities, and you can optimize your application, right? So in those phases of optimization, you can decompose your database into multiple databases and multiple database technologies. Okay, so in that sense, that's why what we did is in this module is we looked at all 4. Right, we looked at all 4. We didn't go too deep, given the time, right? So we looked at all 4 database technologies at a high level. We spent the most time on RDS, which is the right thing, because RDS will remain, RDS and relational databases will remain the main database, right, for most applications, and that's what we did. And then we also spent a bit of time on DynamoDB, which is a NoSQL offering, right? It's a proprietary service, right? And you don't have to use DynamoDB. You can use, say, MongoDB or Cassandra. These are open source NoSQL technologies. You can run those on EC2 instances yourself, right? So those options are also there. But DynamoDB is AWS's own NoSQL offering. Right, so these 2 I think are very important, and then you have Redshift, which is very important for enterprises, larger enterprises who have traditionally been users of data warehousing technology, but they seem to be moving to Redshift in a very big way. Okay, because Redshift is the fastest growing service in AWS today. All right, and then finally we looked at Elasticache. This is an in-memory cache, which means the data is read. It's a database. It's a database technology. You can have key value pairs. You can have some complex data structures as well. And so it's a database in that sense. However, the data is not stored in the disk. It's stored in memory, where it is possible to read very, very quickly. Right. So you would normally combine Elasticache with say RDS or with NoSQL, where the data would be persisted in the regular database, right, and would be stored also in memory with something like Elasticache, right? So this way you can read certain types of data very fast using the cache. Right, and also using the cache helps because you offload some requests away, from the main database into the cache. So this can make your main database perform better. You may also need less capacity there. Thereby, you can also reduce the load on your main database. Okay, so these are the 4 technologies we looked at. We saw how to launch. Right, we saw how to launch and create the instances or clusters. We also saw in each case how to connect. Right, how to connect or interact with these technologies. Okay, so that's what we did in the previous module. All right, now let me also tell you guys that we have there's a bunch of quiz items here. So you should be doing this, right? You should try and test yourself using the quiz that are available here. There's a bunch of questions on each topic that we have covered, right? So it's a good way to sort of review what you know, and if you're not familiar with certain topics, you can go back and read around that particular topic. Okay, so you should use this to sort of test yourself. All right, so So for example, we have this quiz for each of the four topics mentioned here, right? So each of the four database services that we have discussed. And what we can do in module 10, remember module 10 is where we have an open session, right? So if based on how based on these questions in the quiz, right, you may want some clarification, right? You may want to discuss certain topics. We can do all that in that module. All right. Okay. Okay. So Vivek, I think, has a bit of problem with audio. I hope nobody else has a problem. Right. So let me just write to Vivek here. Yeah. So Vivek, it looks like it's a problem on your side. If you can hear me, right, and I'm also sending a message to Vivek here. All right. Okay. So this was module 5, right? And we've actually, we're at the midway point, just about at the midway point. And what I like to do at this point is to also do a survey, right? Just to see how you're doing and what you think of the course. Is there any way in which we can improve for the remainder of the course, right? And also, of course, for future batches. Now, I've been looking at the feedback. Right, a lot of you have been providing feedback after every session, right? Well, not a lot of you, some of you, right? And some of you have also written comments on how we can improve things like too much time being spent on questions, and also the examples are on Mac, not on Windows, right? So those kinds of things, which I appreciate, right? So thank you very much, right, for taking the time to write the feedback. It's very important. I look forward to it keenly, right? And we try to sort of implement changes based on the feedback, actually. All right, but it's a very sort of short survey, right? So what I like to do is, at this point, at the middle of the course, I like to do this survey, just trying to get your feedback on specific aspects of the course. Okay, so this feedback is available in this sheet here. So I'll really appreciate it if you can take the time and fill this form right today, maybe after the session today. Okay, so please do that. All right, and what we'll do is for this module, we'll use this particular sheet here, mod 6 high availability, right? So although it's not just about high availability, but let's use this sheet. All right, okay, so what's the agenda, right? Let's talk about today's module. This this module we have only 2 hours because we took an hour more for the previous module, so we need to finish this today. Okay, so what we're going to do today is we will see how to create an application or a stack which is highly available. It's also fault tolerant, right? They are related concepts, and also scalable. Okay, so you have, say, a Java application or a PHP application or any other .NET or whatever it is, right? And you want to have a highly available, fault tolerant, scalable site. Right, and obviously this is for a live site, a production site, a serious site, right? We're not talking about test environments here. We're talking about live environments. Okay, so it's easy to do that using 2 features or 2 sort of capabilities of EC2. Okay, so these are not separate services. They are part of the EC2 service, and these 2 components, let's say, are one, the load balancer. It's called the elastic load balancer. So we'll understand what it is, how do we use it, how do we implement it. Okay, and the other capability is what is called auto scaling groups. Okay, so these are essentially a fleet or a group of EC2 instances, right? And collectively you can manage them. For example, if you want to scale them, it's very simple. You don't have to manually create more servers, right? When you want to scale a group, you simply say, how many servers you want, right? And the auto scaling group will go and create servers on its own. Okay, so these 2 capabilities give you a very simple way of creating a highly available, fault-tolerant, scalable site. Okay, so that's what we want to do here, and we'll understand. So basically, the same model. We'll look at some slides, understand the concept, and then I'm going to show you a demonstration where we'll implement a load balancer. and we'll also implement an auto scaling group. Okay, and we'll see all this working end to end. Okay, we'll see all this working end to end. Now today we're not talking about databases though. Okay, although to have a really highly available fault tolerant site, you also need to take care of the database tier, right? So you need to make sure that your database also is fault tolerant, for example, right? And that you can do with RDS, for instance, by using the multi-AZ deployment option, right? Where you have a primary server, you have a secondary server, you have replication, right? And the two servers, the primary and the secondary, are always in two different zones. Okay, so we're not talking about that today, although that's part of this topic, right? So, so you have to take care of the database tier as well when we talk about high availability. Okay, so that's the agenda. We'll start with the load balancer. We'll discuss it. We'll implement the load balancer first, and then we'll implement the load balancer with standalone instances first, right? And then in the next part, in the second part of our session today, we'll replace those standalone instances with an auto scaling group. Right? It makes sense always to use auto scaling groups instead of standalone EC2 instances. Okay, so we'll do it in this way, two parts. First, the load balancer with standalone instances, and then load balancer with auto scaling group. All right, so let's start with the load balancer. All right, so you know, the load balancer. First of all, what is it? You know, why do we need it? Right? Let's understand that. So what happens is, you know, we're talking about fault tolerance, for example, right? Or we're talking about high availability. And the easiest way to do that is to have multiple instances, right? So in the past, what used to happen is, you know, the people used to get sort of high availability and fault tolerance at a server level, right? So you had, say, companies like IBM or Sun, Solaris, right? So those kinds of things. So it used to be done at a hardware level, but now the thinking is, look, let's use commodity servers, right? Let's use cheap servers. We can't keep paying the likes of IBM or Sun too much money, right? Especially when we have very large businesses like Google or Facebook, right? Imagine Facebook or Google using, huge farms of IBM servers, right? Or Solaris servers or Sun servers, right? That would be too expensive, and we would not have Facebook and Google if that were the case, right? So the reason we have Facebook and Google today and the scale that they have is because they have basically used commoditized hardware, right? Cheap Intel-based hardware, right? That's the reason we have them. Otherwise, it would be too difficult. Okay. So the way to get high availability and fault tolerance is to use a lot of cheap servers, right? And if one server has a failure, we don't worry so much about it. We just throw it, right? And maybe we can create a replacement server. Okay. So it has to be multiple servers, right? So at the minimum, you should have two. So let's say you have web servers, right? You have app servers, you have a database tier as well. So you should have at the minimum 2 web servers, right? And then you should have 2 app servers at the minimum. And then the database, of course, you will have a primary and a secondary, right? So you can't have horizontal scalability with the relational database. So you always have a primary server and then a standby server. Okay, so 2 web servers, 2 app servers, and a primary database with a secondary database, right? This will give you the basic highly available stack, right? Okay. Now also in the cloud in AWS you have this availability zones as well, right? And this is important because like we discussed before, these are independent. They have their own power supply, own internet connection. If there's a problem, say with the power supply, only one zone is affected, right? The other zone is not affected. So in AWS, what you can do is to get high availability, you'll have 2 servers, right? Let's say 2 web servers, and those 2 web servers should be in 2 availability zones, right? As soon as you do that, it's magical, right? You suddenly you have a very highly available site. Okay, and also fault tolerance. So server goes down, right? You still have other servers. Zone goes down, you still have the other zone, right? So that's how you get high availability and fault tolerance. Okay, so basically we need multiple servers, we need multiple zones, right? But then there's a problem. The problem is, how will the user know, right? Your application has users, and how will they know which server to go to, right? and that's the problem that the load balancer solves, right? So the load balancer job is simply to sort of distribute the user requests to the servers which are running behind it, right, in multiple availability zones. Okay, so that's it. It just you know, you have to point your DNS name, right? Let's say you have a domain name, yourcompany.com or yourproduct.com, right? So that has to be pointed not to a web server, right, or to a certain IP address. You have to point the domain to the load balancer's endpoint, right? And as soon as you do that, you know, users of your application will automatically be hitting the load balancer, not the web servers, right? And then the load balancer has the capability to distribute those requests to the servers running behind it. Okay, all right. So that's what a load balancer does. That's why we need it, right? We need it to sort of handle, to have multiple servers, multiple zones. Okay. Okay. Now you can see here, you know, from this page, from this slide, you can sort of figure out that the load balancer can work with servers in multiple zones, right? That's an important capability. It can not only distribute to multiple servers, it can distribute to multiple servers in multiple zones, right? However, the load balancer can only work within one region. Okay, it doesn't work across two regions. All right, one more capability of the load balancer is what is called the health check. Okay, so it does a health check of the servers that are running behind it, and it does a health check by simply, you know, doing some kind of a ping, right? So it does a ping of each server. So you may have 100 servers behind the load balancer, right? And the load balancer will automatically ping each server, each of the 100 servers, right? And it will keep doing it at a set frequency, say every minute or every half a minute, right? So it keeps pinging each server, and if it doesn't receive a response from one of the servers, right, it basically, you know, will declare that that server is unhealthy, right? It thinks that that server is unhealthy, and it will stop sending traffic. It will stop forwarding requests to that unhealthy server. Okay, why does it do that? Because this way the user will not see a problem, right? If a server is down and the load balancer forwards a request to the server which is down, the user will see a timeout, right? That's not good. So, so the health check is an important function of the load balancer, and it basically improves the user experience, improves the uptime of your application. All right. Okay. Now, also you have to know that the load balancer is a fully managed service. Okay. You don't have to do anything with it. You just have to set it up and configure it, and it scales automatically from a very low volume to a very large volume. Right. You don't have to do anything. It will scale in a fully automated fashion. You don't have to do anything to scale it. You don't have to patch it, upgrade it, or anything. Right? There's no other operation required from your side. You simply have to set it up, configure it to work with your web servers or application servers, and that's it. Right? It will work on its own. Okay, all right. So that's what a load balancer is. So now let's take a look. Right? Let's take a look. There's not much you know, theory to discuss here. Let's take a look at this. Okay, so it's part of the EC2 service. Okay, so you won't find it separately in the, you know, as a separate service. So you have to go into EC2 and let me just change to US East region. All right, so now here you can see this is our, you know, this is something which is familiar to you. This is our EC2 dashboard, and you'll find if you scroll down in the menu, you'll find load balancing as a section available here. Right, so this is load balancing, and you can see there are two options here: load balancers and target groups. We'll discuss that. Right, and just below that you have auto scaling as well. So these are sort of you know, sections within the EC2 service. Okay, so let's, you know, go ahead straight away and let's create our load balancer. Okay, so I'm going to click this button here, The first thing we do is choose the type of load balancer. Okay, and this the application load balancer is actually very new. It's just in the last few months that it has been launched, right? So before this we had what is now called the classic load balancer. Okay, so let's use the application load balancer. Whenever you have the word classic, it means it's a little bit old, right? So you can sort of avoid that. We'll discuss the differences between the two at some point, but for the moment, let's use the application load balancer. Okay, so I'm going to give this a name. Let's say my ELB, something like that. All right, and we have a listener here. You can see there's a listener here. This is an HTTP listener on port 80. Okay, which means the load balancer will accept request. It's listening on port 80, right? So it'll accept a request on port 80. It won't really listen, to a request on any other port. Okay, so you can't hit the load balancer on any other port and expect a response. It's simply not listening. Okay, you can add, although we'll not do this today, you can add an HTTPS listener as well. Okay, this means you may have some pages in your application which need to be secure, right? So they need to have that SSL certificate, if you like that, if you want that, you can do this as well. Okay, so you can have two listeners, one 80 port 80, one 443. All right. Now with this, normally with 443 with HTTPS, you need to install a certificate, right? An SSL certificate has to be installed, and normally before earlier we used to sort of install the certificate on the web server, right? So if you have Apache web server or on Windows, you may have IIS web server. So that's where the certificate used to be installed. But it makes a lot of sense to sort of install the certificate at the load balancer. Okay, so at a single place you can sort of install the certificate, right? So the SSL connection terminates at the load balancer, and then from the load balancer to the server, it's plain regular connection. Okay, so it makes sense to install the certificate at the load balancer, and there is there is a service in AWS called Amazon Certificate Manager, right? And you can sort of get a certificate issued for your domain free of cost. All right, a free certificate. Normally, if you go to say GoDaddy.com or something like that, you'll find the certificates are very expensive, right? But here you get a certificate free of cost, and also the installation of the certificate is usually a problem. It's hard to install it, and sometimes it doesn't work. During renewals, you may have problems. Right, so the certificate management and management of the certificates on the servers has been a problem, right? And with ACM, the certificate deployment on the load balancer is very simple. Okay, so I'm just telling you that. Let's not do that today because let's keep things simple. Okay, but if you want to use HTTPS listener, look at ACM, Amazon Certificate Manager, where you can issue a free certificate, and the deployment of the certificate on the load balancer is seamless. Okay, so that's something for you to look at yourself. All right, so now we have this load balancer with this single listener, port 80. Okay, so now let's use the we'll have the load balancer in a VPC, right? You have to do everything in a VPC from now onwards. All right, before you could sort of set a load balancer outside, but now it makes sense to use VPCs for everything. So we'll use the default VPC. Remember the default VPC, which is not very secure, right? So right now I'm using this just for simplicity's sake, right? But eventually you have to create your own VPCs. All right. So this is our VPC, right? And you have to select, how many availability zones you want to use, right? At the minimum, you should have 2, right? It doesn't make sense to have a load balancer with only 1 zone, right? Because you'll have at least 2 servers, right? You'll have at least 2 servers, and it doesn't make sense to have 2 servers in a single zone. Those 2 servers must be, right? Should be in 2 different availability zones, right? That's why we have to select 2 zones here at the minimum. You can have 3 or 4 as well. Okay, the more zones you have, the better. Okay, the more zones you have, the better. Let's say instead of 2 web servers, you have 3 web servers. right? Or instead of 2 web servers, you have 4 web servers. So then you can use, you can distribute those additional servers in additional zones. That is even better. All right. Okay. But for now, let's select 2. Right. Let's select 2. We'll have to make sure that our EC2 instances are in these 2 zones because that's what the load balancer will recognize. Right. Okay. So let's do that. All right. Next step, let's set up the security group. Okay. So the load balancer will have its own security group. All right. So far we've seen security groups with EC2 instances. We've seen it to some extent with the RDS instance as well, right? And normally the way it works is you need to have a security group for each tier, right? So your web servers will have a one security group. Your app servers will have one security group, and your database tier, both the primary and the secondary will have one security group, right? So normally you have 3 security groups for each tier in your application. However, even within the web server tier, you'll have to have 2, one for the load balancer and one for the web servers, right? Then your application tier will have another security group for the application servers load balancer, and then another security group for the application servers themselves, right? So then eventually you should have 5 security groups for a 3-tier stack. All right. Okay. So all that is, for later we can discuss it if you like. But for now, I'm just going to use the default security group, which is very, it's not secure, right? It's a very simple group. Everything is allowed, right? So we're not really looking at security at the moment. We're just using something simple, something easy to get going with. All right. Next, we configure the routing, which means the load balancer has to work with what kinds of servers or which servers, right? So that's what this target group means. Target group is basically a group of servers which the load balancer will work with, right? To which the load balancer will forward requests. Okay. So right now we don't have a target group, so let's just create one. Let's call it myTG. All right. And also this is the health check section, right? Remember we said that load balancers do a health check, right? And the health checks are done to check which servers are healthy and which servers are not, right? It's an ongoing health check. It never stops, right? And if a server is not healthy, then the load balancer will stop sending requests to that server, right? So that's what the health check is. And you can take a look at the advanced health check settings, right? And basically the way it works is, it pings, right? It pings the home page here on port 80, and if it doesn't receive a response within the timeout of 5 seconds, right? All these are configurable, but if it doesn't receive the response within 5 seconds here, 2 times, right? Twice consecutive. If it doesn't receive a successful response within the timeout period, twice in a row, then the server is declared unhealthy. All right. Okay. And no further requests will be sent to that server. All right. One more thing that you should know is that the health check doesn't stop if a server is unhealthy. Right? It still continues every 30 seconds, right? And sometimes a server may come back, right? It may be unhealthy temporarily. Maybe it is overloaded, for example, right? And it becomes okay on its own, right? So it may come back, and then here what happens is, the health check will continue. The load balancer will know that it is responding now, right? But it will wait for 5 consecutive successful responses, right, before it declares the server healthy once again. And if the server becomes healthy, of course the traffic will start flowing to it once again. Okay, so the health check works both for unhealthy instances and instances which become healthy, right? So it's an ongoing process, never stops. All right, so that's done, right? The next step is to register our targets, right? So register our targets, and the targets are basically servers, right? Normally they are servers, but they can also be actually containers, Docker containers, those kinds of things, right? Let's keep things simple today. We're only talking about targets which are instances, EC2 instances. All right, so you can, maybe you want 2 web servers, right? So you should have 2 web servers running, and then you can select them and add them to the target group here. All right, that's what you have to do. But at the moment, we don't have any servers, right? We don't have any servers, so let's skip this step, and we'll register the targets later. Okay, so let's go to the next step, which is a review step. And basically what we're doing is we're creating a internet-facing web server listening on port 80, right? It's running in the default VPC. It has 2 zones, right? Which means it has 2 subnets as well. Both these subnets, by the way, are public subnets, right? And it has a security group which is open, allows traffic, especially on port 80, right? And then there's a health check which will test the instances to see if they are healthy or not. All right? Okay, so that's it. That's how you create a load balancer. All right, so this is your load balancer, and you can look at the details panel here. The main thing to look at here is the DNS name, right? This is the DNS name here, and this is what you will use when you want to test your load balancer, right? So you can copy and paste this DNS name in the browser, right? You can copy and paste this DNS name in the browser, something like this, right? And you can test it. Right now, obviously, there's no server behind it, so it's not doing anything, right? But this is how you can test your load balancer. So this is an important field here, right? Okay, all right. So now going back to our picture here, we have created this load balancer, right? So what we want to do is we want to implement this whole thing. Okay, we want to implement this whole thing in this demonstration, and what we've done just now is create only this load balancer here. Right. Next, we will create these 2 instances, right? And this should have some sort of simple application which we can create easily. Maybe we'll have a HTML page, right? So we'll create a simple HTML application and sort of create the server, right? Then we'll have to create another server, which will be a clone, right? It will be a clone. These servers have to be the same thing, right? The same application, the same version as well. So we'll create the first server first, deploy a simple application on top of it, and then we'll clone that and create a second server. Okay. Now we'll have to make sure that the 2 servers are in 2 different zones. Right? That's what we want. If they're in the same zone, then we don't get the same level of fault tolerance. Right? So 2 servers in 2 different zones. That's what we need to create next. Okay. So let me go ahead and create the first server first. All right. So I'm going to go up a bit here and into instances. Right? And here, let's create our first server. So I'm going to use Ubuntu as usual. You can use whatever you prefer. Right? All this you've seen before. Right? Let's just stick to the default values. Even the security group, normally you'll have a different security group for your web servers, but at the moment, let's use the default security group, which, as you can see here, is very, very open. Right? Everything is allowed. Effectively, the security group is not is down. Right? It's not doing anything really. Okay. So let's review and launch this application. This server, I'm sorry. So we launch this instance here, right? And this should be up very quickly. And then I'm going to SSH into this and deploy the Apache web server, and we'll also create a simple web application, right? So that we can test the whole thing. So let me copy the public IP and let me open up my terminal, right? This is a terminal program, and here I'm going to do an SSH. We'll do an SSH using the public IP address, right? And now this is our Ubuntu server here. All right. Now, what we need is a simple web application on this server, right? So what I'm going to do is I'm going to use apt-get or apt-get, the package manager, right? And we'll install Apache. But first, we always run the update command so that we have the latest package. We have information about the latest package versions. Okay, So apt-get and update, right? And then after this, we will do, let me clear this, and now we'll use apt-get install command to install the Apache web server, right? We need the Apache web server because we want a simple web application running on this instance. All right, so this is our Apache web server, and now what I'm going to do is I'm going to remove the the Apache default page, right? And instead of that, create my own application. Okay, so so the Apache default page is in the document root, the Apache web server's document root, this one here, right? I'm going to remove this, and I will create my own page instead. Okay, and here let's just write one line here, maybe saying something like ELB and auto scaling demo or something like that, right? So this is our simple web application that will be running on this server. Okay, so now I think we can test this. Let me exit this session here from the server, right? And let's go and use the public IP address of this server and test it, right? We test the server. We just want to see if our application is working, right? So it is. You can see this is the HTML file that we had created just now, and now we are seeing a response from this server. Right, so our server is ready. The first server. Okay, the first server is ready. It has, it also has a simple application on it, which is responding on port 80. All right. Okay. Now this should be in one zone, right? Let's make sure that we know what zone this is in. This is looks like it is in 1A, right? It is in 1A, and the load balancer should be fine, right? The load balancer will work with this server because the load balancer has been configured to work with zone 1A and 1C, right? So this much is done. In fact, what we can do is we can now go over to the load balancer, right? And actually, we can go to the target group, which we created earlier, right? And in the targets tab here, you can basically edit and you can add this server, right? This is the server we just created. We can add to registered, which means we are registering this server with the target group, right? Which basically means the load balancer should now work with this server. Right? So we are doing the configuration, making the two talk to each other, right? That's what we're doing by registering the EC2 instance with this target group. Okay, so let me save this, right? Let me save this. And now, if you look at the targets, right, it says here the status of this server is initial, which means it takes a bit of time for the load balancer to recognize, to register the server, right? But soon the status should change, and now you can see it is healthy, right? The status is healthy, which means the instance is now registered with the load balancer. Okay, so what's happening now is, we have a part of this picture complete, right? We have a load balancer and we have one server, right? And now we have registered this server with the target group of this load balancer, right? So this much is done, and therefore we should be able to test our load balancer now, right? We should be able to test our load balancer. So what we'll do now is let me go back to the load balancer, get the DNS name, right? Let's get this DNS name, and if we test this using our browser, we should see our application, right? So the same application, we should see it now, right? If we go to the load balancer, all right, and it does, right? You can see the load balancer is actually forwarding the request to the one server that we have, and now we are seeing a response from that server as well. Okay, so I'm going to share this with you, right? Let me share the load balancer's DNS name with you. You can test it on your browser, right? So you should see the same application here. This is our HTML application that we set up earlier. All right. Now, next, what we need to do is we need to create our second server, right? Because we can't get fault tolerance and high availability without two servers, right, in two different zones. So we need to create a second server, in a second zone. Okay, second server has to be in a second zone. So what I'm going to do next is I'm going to create an army from this server, right? So the army will have everything that this server has, which means it'll have our Apache web server and it'll have our application, right? We don't have to redo all those things. None of that is required in the cloud, right? So we'll just create an army, and using that army, we'll create the second server in a second zone. All right, okay. So let's see how that is done. So this is our server here, right? This is our server here. So we select that from the actions. We say create image, right? So let's create this image. Let's call it. Let's give it a name. My army, something like that, right? And now we have this image. This will take a bit of time, right? Just a bit of time, and then we'll soon have an image available here, right? Once this is ready, we'll use this to create our second server, right? And then we'll test the load balancer once again, just to see whether it's working with two servers or not. Okay, so let's wait for this, right? Let's wait for this. Now, while this is happening, I want to do one more thing, right? Which is, we'll create the second server shortly, but to make this whole thing work fully, right? What I want to do is I want to point a domain to the load balancer, right? So that we don't have to use a long DNS name, right? The users will not use that. The users need to have a proper branded domain name to this load balancer, so that we see the whole stack working end to end, right? So let's go ahead and do that bit here. So I'm going to go to route 53, right? Let's go to route 53, which is our DNS service, and here again, we'll talk about this service later in more detail, but now let's just make sure that we set up a record set, right, pointing to our load balancer. So let me just say my ELB. Let's say this is our domain, right? myelb.paisaflow.com, and here use the alias record type, and from the target list you should be able to find the load balancer listed here, right? So it takes a bit of time, but in a few seconds you should find the load balancer available here. All right, so now you can see it's available, right? So we just select that, and we create the record set, right? That's done. So now we have this domain pointing to our load balancer, right? So this bit is done. All our user requests will now be forwarded to the load balancer. The load balancer will then forward the request to the multiple servers, right? So that's done. Now we can test this, right? So now, instead of using this ugly DNS name, right, which no user will want to use, right, we will use our own domain name. So you can do something like this, right? And now you can see our application is working via this domain name as well, right? So let me send this one to you as well. You can try this out as well. Okay, all right. So this is good, right? This is good. Now we have something almost done, right? We just have to create our second server, and then we'll have a full stack running. So now our army should be ready. It is, right? We can see the army is available now, and we'll use this to launch the second server, right? Now remember, the second server has to come up in a different zone, right? That's very important. So when we launch this server, everything remains the same, right? Everything remains the same, except we need to make sure that the zone is 1C, because our first server is running in 1A, right? So that's a big step. That's an important step right here. Okay, so this is important, and then everything else is the same. No change here, right? So everything else remains the same. It's the same as the first server, right? And we can now launch this second server as well. All right, okay, so now we have two servers, right? Now we have two servers. One is in 1A, zone 1A, and the other one is in zone 1C, which is what we want, right? We want two servers in two different zones. All right, this is coming up. Now, this won't work right away, okay? just launching the second server doesn't mean it'll work with the load balancer, right? We need to register the second server with the target group. Okay, without that, the load balancer will not know about this second server. Okay, so let's go ahead and do that. Go back to target groups, right, and edit the target group, and now register the second server with this target group, right? So let's do that. Okay, so now we have two servers registered, and once we save this, you can inspect your target group, right? You can see there are two servers, right? One is okay, so soon they'll be in healthy state, right? Both should be in a healthy state soon, and once that happens, our entire setup will be complete, right? And we'll have a fully running stack, and this is fault tolerant, and it is highly available. Okay, it's highly available and fault tolerant, not scalable, right? It's not scalable yet. We'll take care of that later. Right now, it's highly available and fault tolerant. All right, I'm just waiting for both to become healthy, right? I'm just waiting for both servers to become healthy, and then we'll complete this demonstration. So now you can see both are healthy, right? Both are healthy. And if you go to your website now, right, you're actually being served by two servers, right? Two web servers running behind a load balancer. All right, okay, so this completes our load balancer section. All right, now let's do a little bit of Q&A around the load balancer, and then we'll talk about the next topic, which is the auto scaling group. All right, okay, folks. So let's look at these questions here. So what's the web server and app server? What's the difference between them? No, so these are different software, right? They are like different software, different layers in an application stack. Okay, so the web server basically is the front end. Normally, the web server sits in the front. In fact, let's look at Rama's comment here, right? So let me just look at this one. Maybe he has already covered this, right? So web server is to serve HTTP requests, right? Which is the front end. So the user is requesting, right? Goes to your application, requests a certain page. So the web server responds, right? And the application server sends the response result as per the business logic. Yeah. So that's broadly, that's what the answer is, right? So so the web server sits in front of the app servers, right? So the web server tier, let's call it, because let's not call it web server, because we're talking about multiple servers, right? So we can have multiple servers here. So it's a web server tier. You can have hundreds of web servers, all right? And this is the front end of your stack, right? And this receives user requests and response, okay, and response, right? The web server in turn talks to the app server. Okay, so then behind this you have an app server tier, and this usually has your application, right? So this is your like Rama says here, this is your business logic, right? Your application. This could be, say, .NET or Java or PHP, right? That is where your business logic is, and the web server contacts the app server, right? And then the app server responds with whatever has to be shown, right, to the user, and the app server may talk to the DB server. Okay, so behind this is your DB server tier, right? And the app server, if it needs to, it goes to the database to get some data from the database, right? So this is what a three-tier architecture is. Okay, this is how it works. All right. So when we use Apache, that's an app server. I'm sorry, a web server. Okay, so example here would be Apache, right? So Apache is a web server, or you have IIS server in Windows, all right? Okay, now app server, you may have, say, something like IBM WebSphere, right? So these are app servers, all right? And of course, the database server is things like Oracle, etc. All right. Now, Babita, it's a very simple example. Can you talk about real-time use cases? Like when you clone, how are the requests transferred? When request fails in one server midway, what happens? How are both servers kept in sync? Okay, so look, when you clone, requests are not transferred. Okay, so cloning is just cloning has nothing to do with the load balancer, right? So first point here is cloning of a server. Cloning of a server is not related to load balancing. Okay, so nothing to do with load balancing here. We are just creating more servers. Right? We're just creating more servers for high availability and fault tolerant purposes. All right, so cloning does nothing as far as the request handling is concerned. All right, the second question is when a request fails in one server midway, what happens? Oh, nothing happens. So, if a request has gone to the server, it's not able to respond, then that request fails. Okay, so request already sent to a server. If there's no response, if it fails, there's no response from the server, the request fails. Okay, so what happens is the user may see a timeout, right? Or maybe it has failed in the sense it has given an error, so the user will see an error, right? So that's what happens if a request fails in the middle. So that's regular behavior, right? If a server fails, either there's a timeout or there's an error message shown to the user. Okay, that's why you have the health check. Okay, so the health check is designed to prevent such things, right? So hopefully the health check will pick up early enough that a server is unhealthy, right? And it won't send a request at all to that server. Okay, but it may not work all the time, right? Because the user may have already gone and it fails at a point where the health check is not yet detected that the server is not functioning. Okay, so but the health check is there to sort of help with this type of scenario. All right, next question is, how are both servers kept in sync? Like, which request will be load balanced? How is this decided in time of failure? No, there's no sync. Okay, there's no sync. There's no need for a sync. And which request will be load balanced? How is this decided in time of failure? No, it's not. There's no sync, no request. The request is not moved over to another server. Nothing like that happens. It's not that complicated. Okay, it's pretty simple. Request is normally there's no sync. Let me just say that here. Okay, no sync between servers. A failed request does not move over to any other server. All right, this is not, it's not that complicated. It's pretty simple. Okay, and how does the load balancer work? The ELB basically does a round robin. Okay, it basically does a round robin. It does some things more than that. For example, it can look at, in some cases, which server is more overloaded, right? It does some things like that. It is more sophisticated, but at the heart of it, it's a round robin mechanism of forwarding requests, right? So round robin forwarding of requests. This is the main logic, right? The main logic of the ELB. Right? There's no synchronization, no handover, no handling of failure, nothing like that. It does a simple round robin of requests. Okay, all right. I don't, there's nothing more complicated than that. If a server is unhealthy, the health check will detect that, hopefully early enough, right? And it will take out that server from the server set. That's it. Okay, that's it. All right. Next question, how is this domain created? You have to register it, right? You have to register a domain. So basically, any question have a free domain name? No free domain name. Okay, so you have to register a domain. Usually it costs about $10 a year, right? Unless you choose something very popular. Okay, so the domain names have a sort of a secondary market. People sort of buy up domain names which they think will become popular. So unless you have the but most domain names are like $10 to $12 a year. You have to register it. You can register it from Route 53. You can also register it or buy it from elsewhere like GoDaddy.com. Okay, so that's how you have to create it. You can do it in Route 53 or companies like GoDaddy.com. All right. Okay. What else? So you talked about serverless databases. Can you please re-explain? Serverless databases. No, look, there is something called serverless computing, which is Lambda, right? There's something called Lambda, and I might have mentioned that S3 is being used as a very basic database, right? It's like as a data source. So instead of running a database all the time, right? Database is a cost, right? Because databases have to be running all the time, whether they are used or not, right? So what people are looking at is, can we use S3, which is very cheap, keep our data there, maybe in a file format or something like that, and then the analytics tool should sort of pick up the data from S3 and sort of do the analysis, right? So this is being used as a data source, or it's being explored as a data source. It's not a database, okay? It is a data source. It's a storage service being used somewhat like a database, okay? So maybe this is what I was referring to, right? But otherwise, the serverless service is called Lambda, right? And this we will discuss maybe, I think, in the next module, right? Next module or module 8, the one after that. Okay, so this we will talk about a little later. All right. Okay, next question. Let's focus on this module, because we have less time, right? Remember, we have module 10 where we have an open session. Okay, so let's keep some questions for that. Okay, Vivek, how would we know which EC2 instance a request is hitting? You don't, right? But why do you care, right? Why should you care about this? Let me know. I mean, you may have a good reason to know that, okay? But let me know, because then I can maybe respond to you. But in general, you don't know, you don't care. Okay, it doesn't matter. It doesn't matter. All right. Let me just, in the meantime, answer the next question here. Load balancer here. We are using software load balancer or any devices like F5. No, we don't use F5. No F5, right? No F5 here. So AWS, this is probably AWS's own technology, right? AWS's own tech, right? They have lots of experience. Remember, this is the same tech that got developed as part of Amazon.com's growth, right? So they'll have their own tech, or they may be using some open source somewhere. We don't know, right? We don't know. We don't care as well, right? Yeah, there is software, and as far as hardware is concerned, it's not a single server. It's a fully managed service. It can scale. It can add more instances as required. So all that is there. All right. Can you stop one instance and see if it still routes to the live instance? Yeah, it will. It will. You can try it. Okay. You should try it yourself. It will definitely work. Okay. I've done it many times. It will definitely work. But what happens is, the health check has to pick it up. All right. The health check has to pick it up. So it may take a bit of time for it to recognize that one server is down. But then once it does that, it'll declare it unhealthy, and it'll keep working with the other server. Okay, you can try it out. I'm going to show something similar to you with auto scaling. That's why I don't want to show it now, but with auto scaling, we'll take a look at something similar. All right, Rao, what happens when the ELB is down? We have one instance of load balancer. How HA is achieved here? That's a good question. Okay, I was in fact expecting that this question will be asked. It's a good question, because if you look at this picture, you can say, well, it's good that you have multiple servers, right? That's good. One server is down, the other will work. Also, it's good that we have multiple availability zones, right? One zone is down, it will still work. But what about the load balancer? It seems like a single point of failure, right? That's what that question is about. That's a good question, right? So the point is that it's not a single server. Okay, it's a representation here. It's actually a fully managed service. It's highly scalable. It is already high availability. All that is built in. Okay, you don't have to do anything. It's a managed service, highly available, highly scalable. Okay, so it's not a single point of failure. Okay, so it's a fully managed, highly available, scalable component. All right. Is it the same steps you used to create app servers? Maybe have the commands to import WebLogic on EC2. Yeah, same steps, right? Similar steps. Remember that the app server ELB will be what is known as an internal load balancer. Okay, this one is an external, internet facing, right? The only difference is the app server ELB has to be an internal load balancer. Okay, but otherwise it's the same steps. And can we have the commands to import WebLogic on EC2? There's no import. Okay, you can use the WebLogic army, right? WebLogic army, just find that and you have the server up and running. Or you can install, WebLogic yourself, right? On an EC2 instance, right? So the way you install WebLogic on your servers today, the same steps you can follow on an EC2 instance. Right, assuming you have all the licensing taken care of, right? It's the same thing. EC2 instance is like any other server. Whatever you do today, you can do it, right? But something simple is to just choose the WebLogic army and start using that right away. All right, okay. Next question, can you create a load balancer one more time and explain? Okay, let's see. Let's we'll see if we have time. We'll do this maybe at the end of the session. Okay, because we are running a little bit of short of time. And we'll discuss the load balancer once again as part of the auto scaling group as well. Okay, so let me skip this. If required, we'll do it again at the end of the session. All right. Subhani, one instance files are modified. How to sync that modified file in another instance? No. So this, we are talking about DevOps and things like that, right? So you don't do things like this. So, so your question is, how do we update? Right? How do we update our EC2 instances behind the load balancer? Right. So that's a bigger question. Okay. So there are many ways of doing it. You can use tools like there are deployment tools available which can automate all this for you. You can use configuration management tools, right? You can also do it in a manual way, in a simpler way. For example, some of the ways that you can do this is, so there are many options. The simplest one is you have to create a new army, right? With say your updated application. Let's say your application has to be updated, right? You have a new version of your application, so you create a new army, okay, for your server, and then you have to sort of create new servers with that new army, right? Create 2 more servers with this new army, right? Okay, register these 2 servers in your target group, all right, and then terminate the old servers. Okay, this is one way of doing it. There are many other ways, and in fact, you should use auto scaling groups and things like that, right? And there are many other ways. For example, so it's a simple way. Right? It's a simple way. You can use it for a small application, maybe, right? But other options, right? There are many other options. For example, if you talk about DevOps and things like that, there's something called code deploy, for example. Right? This is a service from AWS. You can investigate that. You can use config management tools. For example, Chef, Puppet, Ansible, right? You can also use what are called bootstrapping scripts. right? You can also, right? So there are many ways. Okay, this is a different topic. It's a bigger topic. Okay, we don't have time for that, but I've given you some options to think about. All right. If I try to create a, if I try to register a domain, if I try to create a domain, it's not showing. Yeah, so I saw your email, but I've replied to you. Okay, I can't see one of your files, right? So you have to explain what the problem is. Okay, you have to explain what the problem is. I'm not able to understand. Okay, so here explain your problem in detail, and I can't open the .mht file, right? So just you can just let me know there, right? So I've replied to you. You have to, the ball is in your court. Okay. All right, Sashi, if it has dynamic database content, then ultimately pressure goes on the database. Yeah. True. So yeah, this question, what you're saying is, look, it's fine. You can scale this, right? You can have many servers here. You have many web servers, many application servers, right? But what about the database? Right? You'll have lots of requests going into the database. So yes, so your database has to be scaled as well. Okay, so your database has to be scaled, and usually the database is vertically scaled. So your DB has to be scaled up. Okay, it's called up, which means vertical scaling. Right? You have to have larger server. Okay, a bigger server is what you need with on the database side, because you can't really scale it horizontally. All right, but remember, with RDS you have what is called read replicas, right, which you can use to do horizontal scaling of the read requests, at least, right, of the read workload at least, right? So this is one option that is available, but otherwise normally, yes, you have to vertically scale the database tier to keep abreast of the requests coming from the app servers and web servers. All right, okay, folks. So now this is the load balancer, right? Now this is the load balancer. Let's talk about the next topic, which is the auto scaling group. Okay, so the auto scaling group is all right, so this is basically a group of EC2 instances, right? And it's called auto scaling. It has multiple features. It's not just for scaling purposes. Okay, it has multiple features, but I think the most impressive feature is that it can scale automatically, right? Which means, and we are talking about horizontal scalability here, right? So when we say horizontal, what we mean is more servers. Okay, so you have, say, 2 servers. You want to have more capacity, so you go from 2 servers to 4 servers, right? Or 6 servers, or 8 servers, or 10, or 50, or 100. You can go to many servers, right? And the most impressive quality of auto scaling group is that the increase can be increase or decrease, right? The scale out or scale in can be fully automated. So depending on the load, the number of servers will increase or decrease automatically, right? That's why it's called auto scaling group. Okay, but it has other properties as well. So let's just understand this a bit. Okay, so here, in our picture that we saw earlier with the load balancer, we had 2 instances, right? And this is like a fixed standalone instances, 2 standalone instances, right? And what we want to do actually is to, instead of using standalone instances, we want to use an auto scaling group, right? It's a group of servers. The group of servers can be 2, right? Or it can be more, but it's a group of servers, and you manage the group as a whole, right? Instead of managing each server individually. Okay, so what you do is you create a group, all right, and then you can define things like what's the desired capacity. Right? This is a very important field, by the way, desired capacity. So you simply say, okay, let's have a group, and I want 4 servers or 10 servers, right? And the group will automatically create those servers for you, right? In the previous demonstration, we saw that we had to create the first server, then we had to, use the army to create the second server, right? All this is done manually. But in the auto scaling group, you don't have to do anything like that. You simply say, okay, I want 4 servers or 10 servers, right? And those servers will come up automatically, right? And that's one of the strengths of a group, right? It's more automated. You don't have to do manually lots of things, right? Everything happens automatically. Okay, so you basically create a group with a desired capacity, and the number of servers will be automatically created for you. All right. Okay, this is one bit. What is the benefit of this, right? There are multiple benefits actually. For example, the automated provisioning we spoke about, right? We spoke about the automated provisioning where you don't have to manually create servers, right? And you don't have to manually delete servers as well, because the auto scaling group can be scaled in as well. Right? If you want fewer servers, it can be scaled in automatically as well. You don't have to go and delete servers individually; it will delete it itself. Okay, it's very flexible, right? The capacity is very flexible. You simply, if you have a desired capacity of 10, you want to go to 20, right? Simply change the desired capacity, and 10 more servers will come up for you, right? So it's very flexible. The whole group can be managed in a very simple manner as compared to managing it on a standalone basis. All right, now let me show you a few more things about this, right? So let's talk about how to implement this, right? Let's talk about how to implement this. Okay, so first we have to create a group. Okay, now to create a group, we need a configuration, right? We need a launch configuration. Basically, we have to define things like what's the army to be used, what's the security group, what's the key pair, right? So those kinds of things have to be used, have to be configured, right? And then we sort of attach that to a group, and then the group comes up based on the launch configuration. All right. Once the group comes up, you can scale it, right? You can scale the group manually on a schedule or in an automated fashion. All right. So let's try and understand how this works. Okay. So first we'll create a group of servers, right? It's called auto scaling group, ASG, right? And here you can have instances. You can have any number of instances. You can also define what zones you want to use, right? So the number of instances is distributed in an intelligent fashion in the zones that you specify, right? So let's say you say you want 4 servers, and you say you want these servers in 2 zones, zone A and zone B, right? So the auto scaling group will create these servers intelligently, right, in such a way that there are 2 servers in each zone, right? So there's a lot of intelligence in the auto scaling group. It makes sure that your servers are distributed evenly, right, which is what you want for fault tolerant and high availability purposes. Right? If you have a group of 4 servers and it creates all 4 in one zone, that would not be a smart thing, right? So it has the intelligence to create it in such a way that you have the maximum fault tolerance and the maximum high availability. Okay, so this is how you do it. You have to define a desired capacity. You have to define what zones you want to use, and then the servers will be created in an intelligent fashion automatically by the auto scaling group. Okay. Okay, all right. Now a few more things here, right? One is you also set in addition to the desired capacity, you also set the minimum and maximum, right? The minimum number of servers and the maximum number of servers. This comes in use later when you try to scale the group, right? And especially when you try to scale the group automatically based on the load, right? So if the load increases, the number of servers will be increased automatically, right? But it can keep on increasing, right? That's why you place a maximum on it, so that your cost doesn't go out of whack, right? So you have to have a maximum so that the server growth is not too much, right? Doesn't go beyond your maximum. And for the same reason, you have a minimum so that the servers can be terminated automatically based on the load. If there's no load, the servers will keep getting removed, right? So that your cost is under control. But of course, you don't want the number of servers to go below a minimum, right? Because the minimum is 0, so it can delete all the servers. So that's why you should set a minimum, say 2. A minimum of 2, a minimum of 4, right? Whatever you think is appropriate. All right. So you have the desired number of servers, you have the maximum number and the minimum number. These 3 things are required to create your auto scaling group. Okay. One more point. There's a health check. Remember, the load balancer has a health check, right? That's different. The auto scaling group also has a health check, and this health check is used by the auto scaling group to determine which instances are unhealthy. All right. And then it can replace the unhealthy instance with a healthy instance on its own. All right. Okay. Why? Because the auto scaling group always maintains the desired capacity, right? So if your desired capacity is 10, one of the servers becomes unhealthy, right? So your desired capacity is only, your actual capacity is only 9 now, right? Compared to a desired capacity of 10. So the auto scaling group does not like that. Okay. So it's going to act. It will remove the unhealthy instance and replace it with a healthy instance. Okay, so this is another reason to use auto scaling group, right? It is self-healing. It can heal itself. It can fix itself. Okay, all right. So this is a auto scaling group. All right, now before you create an auto scaling group, you need to create a launch configuration, right? It's just a configuration. It's not a real group of servers. It's only a configuration, and we need this because we need to define things like what's the army, right? What's the type of instance? What's the key pair to be used, right? The same things that we define when we create a standalone EC2 instance, right, has to be defined for the group of servers as well, right? The only difference is, these configurations apply to the whole group instead of individual EC2 instances, right? So that's what a configuration is. It's just the usual stuff defined for the whole group of servers, all right? So we'll see how to create a launch configuration as well. All right, and then it comes to scaling, right? The whole reason why we're using auto scaling groups is that we want to scale this group of servers, right? And there are 4 options available to you. Okay, so there's a fixed option, which means the auto scaling group is not really being scaled, right? It's just a fixed number of servers. Okay, so even though you have a fixed number of servers, it still makes sense to use auto scaling. All right, why? Because it's easy to manage a group, right? You don't have to launch servers individually. You don't have to terminate them individually, right? Also, the auto scaling group is self-healing. It always maintains desired capacity, right? So it's fault tolerant in that sense. Okay, so the auto scaling group makes sense even if you don't want to scale, right? Even if you have a very stable application, you have X number of servers, you don't really need to change that. Even then, it makes sense to use auto scaling group instead of using standalone instances. All right, so that's one option. No change, no scaling, just fixed, but still makes sense. All right, next is manual scaling, right? Manual scaling, for example, let's say you have a e-commerce business, right? You're an e-commerce company, and e-commerce companies are interesting because they have festival sales periods, right? I mean, I'm just trying to explain these scaling options using some real life examples, right? So e-commerce companies have festival sales, right? In the US, you might have heard of this. There's a Thanksgiving period, right? Thanksgiving holidays, right? It's usually like a weekend or something. And for those during that time, during those 2 or 3 days, you have very high sales, right? Both physical stores as well as online stores, right? And even in India, for example, here, the local e-commerce companies, they are trying the same thing, the Diwali sales, right? In this country, Diwali has always been the time when people buy, throw away the old things and buy new things, right? So that's what is happening in this country as well, and I'm sure in all across the world, right? So here, what happens is in the e-commerce world, that the festival sales will have a lot more transactions, right? It could be 5 times, 10 times, even more times the regular volumes that they have, right? So they know in advance, it's predictable, right? They know the dates when they need more capacity, right? It's easy. So what you can do is you can simply go and manually increase the size of your group, right? You can change the desired capacity, say, from 10 to 50, right? You need 5 times the capacity. So change from say 5 to, say from 10 servers to 50 servers, 5x, right? Or whatever number you want. Right, so it's easy to go and manually change. You don't have to do anything fancy, right? Manual is best. If you can do it, manual is best, right? So just 1 day before, go and change the desired capacity. Right after you change the desired capacity, you'll have more servers created automatically for you, right? And then once the sales period is over, 2 or 3 days later, right, you want to come back to your normal capacity. So again, go and change the desired capacity back to whatever lower number you have. Okay, so that's an example of a manual scaling. All right, next is schedule scaling, right? So you can basically say, okay, at a certain time I want more servers, at a certain other time I want less servers, right? And this should be on a schedule, say on a daily schedule, weekly schedule, or whatever. Okay, so this you can do. And a use case is, let's say some business applications, right? So let's say you have a company, you have customer relationship management software, sales management software, HR software, right? Accounting software. So these are business applications which most companies use, right? And the usage pattern there is very, very well established, right? Most usage happens during office hours, right? 9 a.m. to 5 p.m. let's say. Okay, Mondays to Fridays, 9 a.m. to 5 p.m. is your usage, right? So you don't really need too much capacity in the night right? Or too much capacity on weekends, right? So what you can do is you can set a rule with auto scaling groups where you say, okay, every morning at 9 o'clock, have X number of servers, right? And then every evening at 5 p.m., bring down the number of servers to 0 or to a smaller number, right? So this way, it takes a few minutes to create this kind of policy, and this way you have more servers when you need it, you have less servers, right, when you don't need them. Okay, this is great because, by the way, this will save you a lot of cost as well, right? It will save you a lot of cost because remember, the working hours are only 1/3 of a day, right? 8 hours out of 24, right? So you can cut your cost to 1/3 simply by creating this kind of schedule policy, right? In fact, you'll save more because we're not counting Saturdays and Sundays, right? So you can, maybe it'll be 20% of your regular cost simply by using scheduled policies. All right. Okay. Now, finally, there's dynamic scaling as well, right? Dynamic scaling. So what happens here is that sometimes there are some use cases where you cannot predict the usage pattern, right? So in the two previous examples, the e-commerce example and the business applications examples, you can understand, right, that there's a predictable pattern, there's a well-established pattern, right? In advance, so you can either use a manual scaling or a scheduled scaling, right? But there are some applications where it's not possible to predict the usage, it's not possible to predict the load, right? For example, media sites, right? Media sites. So let's say you have CNN, right? CNN news. Or you have sports websites, sports sites like ESPN, Cricinfo, right? Or maybe some site where you're watching football or soccer, right? So there, what happens is, especially news, right? Let's say there's some, North Korea does something, right? Or Donald Trump says something, right? So you can certainly have events, right? Which are unpredictable, of course, and that can lead to a very sharp increase in the usage, right? In sports, you know when the match, right? Say a Champions League match or a World Cup match, right? You know when it is, but you don't know when the goal will be scored, right? Or when a certain player hits a century in cricket, right? You don't know all those things. So these are situations where you can't predict, right? So in those cases, you have no choice but to use the dynamic policy, where you can define rules like, okay, if the load is high, right? If the load is high, add more servers, right? And if the load is low, remove servers. Okay, so when the load increases, number of servers increases automatically. When the load decreases, number of servers decreases automatically, right? So this kind of dynamic policy is also possible. Okay, so now let's see how to implement the auto scaling group. So what I'm going to do now, right? What I'm going to do now is, if you look at our load balancer screen here, right? So if you look at our load balancer screen here, this one, right? This is what we had implemented earlier, right? So now what I'm going to do is I'm going to replace these standalone instances, okay, with an auto scaling group. All right. Now remember, my recommendation to you is that you should always use auto scaling groups, all right, and not use standalone instances in this fashion, right? What is shown on the slide is not a good idea. Instead, use auto scaling groups. Okay, for the reasons we have explained, which is, one is it is self-healing, two is it is very easy to scale, right? Three is it is easy to manage, right? You don't have to do things manually. Servers come up, servers are removed automatically, right? So lots of automation is there, lots of self-healing, right? Scalability is very good. Okay, so for that reason, it always makes sense to use auto scaling groups and not standalone instances in this fashion. Okay, so what I'm going to do next is, we'll create an auto scaling group and connect it to the load balancer, right? And before that, we will remove these two instances because we don't need them, right? We don't need standalone instances. It makes sense to use auto scaling groups. Okay, so first, let me remove these servers. All right, let's do the simple things. Let me go over here and remove these two servers. All right, so standalone instances are being terminated. Okay, that's done. All right, now instead what we want to do is create an auto scaling group. It's a much better idea, right? So we go to auto scaling here, just below load balancing, right? This is auto scaling. And the first step is to create a launch configuration, right? It's just a launch configuration. It doesn't do anything. It's just a configuration. Let's create the launch configuration first. All right. So let's, first step is to create an army, right? You have to basically define the same things that you define for a standalone instance, right? But a launch configuration is for a group of instances, right? So it's the same thing, but for a group of servers, all right? So as usual, we have to define the army, and here we'll use our own army, right? Not use Ubuntu, we'll use this army because this has our web application, right? It has this application already, right? That's what we want to use. So in the launch configuration, we will select our own army. Okay, everything else remains the same, right? We can use micro instances. All right, let's give this a name. Let's call it my launch configuration. All right, so this is fine. Everything else is the same. This is the EBS volume. Let's use the same security group. All right, and also let's use the same key pair, right? So it's the same stuff that we use for individual servers, this time for a group of servers. Okay, not complicated. It's not complicated. So we just create a launch configuration, right? Okay, so this is your launch configuration, right? It's just a configuration file. All right, now we use this configuration to create our auto scaling group, right? This is where the real servers will come up. Okay, so let's select this one. Okay, let's give it a name. Let's say my ASG, right? Let's say my ASG. All right, and now let's start defining stuff here, right? So first of all, let's say the group size is going to be 2. Okay, minimum of 2. It doesn't make sense to have a single server, right? Minimum of 2. And you can have more, of course, right? You can have 3, 4, 10, 100, right? All those things are fine, but at least minimum, at least 2 servers you should have, right? When you're using load balancers or when you want a highly available site. So let's start with 2. Okay, this is going to be in a VPC. Everything should always be in a VPC, all right? And we'll also have to select what zones we want to use for our auto scaling group, right? So we'll use 1A and 1C because our load balancer is also configured to work with these 2 zones. Okay, so that we have to take care of. Make sure that your load balancer and auto scaling group is in sync when it comes to which zones both components will be using. All right, so we've selected the zones as well, right? So we are saying 2 servers in 2 zones, which means auto scaling will automatically create 1 server in each zone. All right, okay. Next is scaling policies. So what we'll do is we'll keep this at a fixed size initially. Later we will see how to set up the scaling policies, right? Let's keep it at a fixed size. All right, these steps you can skip for the moment, right? And this is a review page. Basically, we're creating an auto scaling group using that launch configuration. The group size is 2, so there'll be 2 servers, and there are 2 subnets that we have defined. All right, it's a fixed group as well at the moment. All right, so let's create this auto scaling group, right? It's done. All right, now you can see here the desired capacity is 2, but the actual number of servers is 0, right? There's no servers at the moment in this group. Okay, this auto scaling does not like. It always will ensure that your actual number of servers is the same as the desired number of servers, right? So what does it do? It goes and creates 2 servers for you, right? We are not creating these servers. The auto scaling group is doing that. Okay, you can now see 2 servers are coming up, right? Why? Because the desired capacity is 2, right? Desired capacity is 2, so auto scaling has launched 2 servers. All right, now the 2 servers will have the same software as our application because we've used the same army, right? We've used the right army, so these 2 servers are actually the same as our previous 2 servers. Okay, all right, okay. Now, so what we've done is, we've replaced these 2 servers, standalone servers. We've created an auto scaling group which is quite similar. It uses the same zones, it has the same number of servers, right? It's the same thing, except it's in an auto scaling group. Okay, now we also need to connect the load balancer and the auto scaling group, right? So we need to do that. So let's do that, and then we'll test our application. So here, what I'm going to do now, you can see the 2 servers have come up, right? They are both in a healthy state. So what we need to do now is you can go to the details tab of the auto scaling group, right? And you can see the target group field is available. It's empty right now. right? So we can edit the auto scaling group and we can supply our target group, right? This is the target group which is associated with our load balancer, right? So just by doing this, we are connecting the load balancer and the auto scaling group, right? And the two will talk to each other, right? We after this, we don't have to make them, we don't have to do any configuration after this. The servers will come, servers will go, load balancer will know about those new servers, right? And there's no need for any further configuration, right? We just have to connect the load balancer with the auto scaling group using the target group setting. All right, so that's it. Okay, that's it. Now we have connected the two. All right, now our setup is complete, right? This whole setup is now complete, with the difference that, instead of standalone instances, we have an auto scaling group here. All right, that's it. So let's test our application, right? So let me test our application. Let's give it a few seconds because it takes time for the load balancer to register, right? Let's just give it a few seconds and it should soon be available. Okay, we can test it. We can actually go and check what's happening. So you can go to the load balancing section, right? Look at the target groups, and in the target group, the instances may be still in the process of being registered, right? So we can check this. Yeah, you can see it's still in an initial state, right? That's why we're not seeing a response. So now they are healthy, right? Now they are healthy. So if you now go to the website, it should work, right? You can now see it is working. All right. Okay, so it's done, right? It's done. We have an auto scaling group being used with a load balancer. This is what you should be doing. Now we need to talk about the scaling, right? Now we need to talk about the scaling. So here, all right. So these four options, right? So right now we have a fixed group. This is good because it is self-healing, right? It is self-healing, which means if one of the servers is unhealthy, that will be replaced, right? That will be replaced automatically. Let's take a look at how this works. Okay, so we have two servers here, right? We have two servers in the auto scaling group here. All right, we have two servers. Okay, now imagine one of the servers becomes unhealthy. There's some hardware problem or something like that, right? So the auto scaling group will replace that because it always maintains desired capacity, right? Now we want to test this. How do we do it? Let me stop one of these instances. All right, so I'm going to stop one of these instances just to simulate a failure, right? So let's take one of these instances and I'm going to stop one of these instances. Okay, it's a graceful stop, so it'll take a bit of time, right? It has to gracefully stop all the services. So now that server is being stopped, right? That server is being stopped. Let's watch what auto scaling does, right? Let's watch what happens. So right now, the servers are shown as healthy, right? But one of these is being stopped right now. So soon, the health check of the auto scaling group should detect that server is down, right? It should happen soon. Let's see. All right, so both are healthy, right? It'll take a bit of time because it may do multiple checks before concluding that it is unhealthy. So let's give it a bit of time. All right, so still not detected, right? Let's wait. Let's wait. Okay, this it takes a bit of time because it's a graceful stop, right? So it has to gracefully stop all the services. So it'll take a bit of time before it goes into a stopped state, right? And then the health check will do multiple checks. So it takes a bit of time. Okay, now you can see this one is unhealthy, right? Now it is unhealthy. Okay, so what will the auto scaling group do? It will basically decide that the desired capacity is not there, right? It's missing one server. So let's take a look, right? Let's see what happens. Okay, so now you can see it is terminating, right? It will terminate the unhealthy server, right? It will terminate the unhealthy server, and at the same time, right? At the same time, it will launch a new server to replace that unhealthy server. Right? So let's take a look at this. All right, any moment now. Now you can see another server is coming up, right? This one is coming up. It's in the pending state. Okay, so soon, the old server will be gone, and the new server will take its place, right? Also note that the new server is coming up in the same zone as the unhealthy server which is being removed, right? So the auto scaling group is intelligently maintaining the right balance, right? It has to make sure that the servers are evenly distributed, right? This is required for fault tolerance purposes, and you can see that is what is happening, right? So now you have two servers, right? Both are healthy, right? Both are healthy, and it looks as if nothing happened, right? You won't even know, but it has fixed the problem on its own. All right, okay. And in the meantime, you have to do no configuration change with the load balancer, right? The load balancer also knows about the fact that one of the servers has been terminated, right? And a replacement server has been created, right? It knows that. You don't have to do anything further, okay? Auto scaling group and load balancer will talk to each other, and they will handle everything. There is no change required from your side, okay? You can see both servers are now in a healthy state. This one is a new one, right? But it looks as if nothing has happened, right? Your application will keep working, okay? Your application will keep working as if nothing has happened, okay? That's what is the fixed option. All right, okay, now the other options, right? Let's quickly take a look at this, and then we'll do some Q&A. So the first one is the manual one, right? Remember the e-commerce use case I told you about, right? So let's say you are the e-commerce company, and tomorrow is your festival period, right? And you need, let's say, double the capacity, okay? So all you have to do that is one day before, you edit your auto scaling group, all right, and set the desired to whatever size you want. So in this case, we want to double the capacity, so I'm going to say 4 here, right? So we want 4 servers, all right? Now the desired has to be between the maximum and minimum. So as a one-time change, I'm going to increase the maximum to 10. All right, so we have set the desired capacity to double our capacity. So now we want 4 servers, right? And now you can see what will happen is the load balancer knows that the actual number of servers is below the desired capacity, right? So that it doesn't like, it will take action. And what action? It will basically launch 2 more servers, right? You can see 2 more servers are coming up, right? And they're coming up in an intelligent fashion. They are evenly distributed. One server coming up in 1A, right? Another server coming up in the other zone. Okay, so a bit of intelligence here, a bit of automation here, right? All you have to do is change the desired capacity, and the rest of the work is done by the auto scaling group, right? No change required with the load balancer, right? Just change the desired capacity. That's it. Okay, now if you want to scale down or scale in rather, right, after the festival sales, let's say you want to go back to your normal capacity, again, change the desired capacity back to 2, and you'll be back to 2. 2 servers will be automatically removed from your auto scaling group. Okay, so that's manual. Okay, what about scheduled? Right, scheduled is, remember, your business applications which are used during office hours. So you don't need too much capacity all the time, right? You need capacity during office hours and less capacity in the night, right, and on weekends. So what you can do is go to scheduled actions, right, and create a pair of actions. It's always a pair, okay? It's always a pair. So let's say this is scheduled scale out policy. All right, so we create a scale out policy, and let's say we say desired capacity will be 4. All right, it will be 4 every day starting from tomorrow. All right, starting from tomorrow at, let's say, 8:55 a.m. All right, at 8:55 a.m. you're setting the desired capacity to 4, which means shortly after that the actual capacity will also become 4. Why? Because auto scaling always ensures actual servers are the same as the desired servers. Okay, so here what we're saying is every day at 8:55 a.m. set the desired capacity to 4. Okay, so that's one of the pair, right? You also have to always create a second action, and this time this is scheduled scale in, right? Scale in, which means you want to reduce the number of servers. And here, let's say in the night, you only want 2 servers. You can also set it to 0, right? But let's say we want to have, for some people who want to work from home, you want to have 2 servers. So this you can set, right? This will also happen every day, starting from tomorrow. And this can happen, say, at 18:05, which is, or 17:05, right? Let's say you work 9 to 5. So 17:05, just after 5 p.m., the number of desired capacity will be set to 2, right? Which means actual servers will also be brought down to 2. Okay, so you have to create a pair of policies for scheduled action, right? In the morning, increase the servers. In the night, decrease the servers. This will save you a lot of money. You can try and calculate, right? Your cost will become 20%, 25% of of the cost if you didn't have these policies. All right, finally, right, you have the automated scaling. Let's say you have CNN, right, or ESPN, Cricinfo, that kind of media site. You can't really predict, right? You don't know what time you need more servers. So you need something automated, right? So what you're going to do here is, again, you'll create a pair of policies, right? Let's say this one, the first one is auto scale out policy, right? And the way it works here is, we'll talk about alarms later, right, when we talk about CloudWatch. But here, what we are doing is, we can say something like, if average CPU is more than 80%, right? And usually you want to, it should be above 80% for a period of time, right? So let's say if it is above 80% for 5 consecutive minutes, right? We always say 5 consecutive minutes or 10 consecutive minutes because, CPU going to 80% is normal. Okay, there's no big deal. It can go to 100%, that's fine, right? As long as it comes back. Okay, but if CPU is high continuously, right, that means your servers are overloaded, right? So that's why we say if CPU, average CPU, right, by the way, it's average CPU of the entire group, not of one server, average CPU of the entire group of servers, right? You may have 100 servers, the average CPU of all those servers together, right, if it is above 80% for 5 consecutive minutes, right, that's the condition. And under those conditions, right, what we want to do is we want to add 2 servers, let's say. Okay, this is your scale out policy. All right, so if CPU is above 80% for a bit of time, you're adding 2 servers. Similarly, you'll add a reverse policy, right? This is a scale in policy, all right? And here, what you have to do is you have to do something like this, where you'll say if CPU falls below 20%, let's say, right? And this time for say 15 or 10 minutes, 10 consecutive minutes, you want to be conservative, right? You want to make sure that the load is gone away, right? It's not a temporary decrease, right? So you say 10 minutes. If it is below 20% for 10 minutes, then I think that the goal has been scored or whatever, right? So we are sure that the load has gone away. So in these conditions, we will remove 2 servers, right? We'll remove 2 servers. All right. So this is your scale in policy. All right. So we have a pair here, one scale out, one scale in, and this will react to the load, right? So what will happen actually is, when the load increases, the group will automatically add 2 more servers, right? If the load is still high, it will again add 2 more, right? And 2 more, and 2 more, and 2 more, till it hits the maximum. Right? It won't go beyond the maximum, okay? Because you have set the maximum. All right. So the maximum has to be set carefully, because if you set it too high, your cost may be too high. If you set it too low, then your application may crash. It may not be able to handle the load, right? So you have to sort of tune all these things, okay? But that's how it works. And also on the reverse side, if the load decreases, 2 servers are removed. If the load is still below 20%, 2 more servers are removed, right? So it keeps decreasing till it hits the minimum, which is 2 servers in this case, right? So during a day, you can watch all this. I've seen this. I've used this a lot, right? And what happens is you can see the actual number of servers moving between minimum and maximum, right? So it goes up, 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 right? Up, down, right? So you can see the actual number of servers moving, right? Some value between the minimum and maximum, right? And this is great because you have more servers when you need them, and you have less servers when you don't need them. Less servers, basically reducing your cost, right? It reduces your cost. Okay, all right. Okay, that's it, folks. This is auto scaling group. So together, right, what you have to understand is you have to use load balancers, you have to use auto scaling group, right? Don't use standalone instances. Auto scaling groups are much better, right? And we use load balancers because it has to be used for when you have multiple servers in multiple zones, right? So very simple, it's very simple. Just a little bit of practice, and magically you can have highly available, fault tolerant, and scalable. Right? Auto scaling gives you that scalability, right? So you have these capabilities in a very simple fashion. You have to include RDS multi-AZ deployment, right? So that will give you the high availability on the database side, right? Today we have looked at the web tier and the app tier, okay? But you have to use RDS as well. All right, that's it, folks. So let's do some more Q&A, and then we can end this session. All right, so let's talk about these questions here. First one, Subani, how will the load balancer and auto-scaling handle DDoS attacks? Is there any backend technology to mitigate this type of attacks? No, these components are not designed for, these are not designed to block DDoS, right? So for those others in the group, DDoS is distributed denial of service attack, right? So what happens is somehow some people, some hackers or some state actors, right? They may launch requests on your application from many devices at the same time, right? So basically overloads the stack, right? So what will happen is it'll crash, right? It'll crash because even if you have auto scaling, you'll hit the maximum number of servers and then it'll crash, right? So it's not designed for DDoS, but AWS has some other services. Okay, AWS has something called you can check out these services. Web application firewall, all right, and so you can see here this one here, WAF and Shield. Okay, these can prevent against DDoS attacks. So you can just review that, okay, and use that along with load balancers and auto scaling. Okay, so use WAF and Shield. You can explore these services. That's meant for DDoS, not these. Okay, next question, Chandra. When the load increases, a new instance is launched, created at that moment instantaneously with all security group storage capacity, or we need to have some EC2 instance created and keep as buffer? No, nothing. No buffer, right? No buffer at all, right? ASG will handle scale out, right? Scale out according to your scale out policies. Okay, nothing else has to be done except creating the policies, which basically configures your scaling. All right, fixed ACG is close to load balancer. Yeah, fixed ACG you can say is close to load balancer with standalone instances, right? Fixed ACG is close or similar to ELB with, or rather to a fixed number of standalone instances, right? So it's similar to that, yes. But ASG is better. Okay, ASG is better because it is self-healing. Right? It is self-healing. It can detect unhealthy instances and replace it, which standalone instances cannot do. Okay, so always use ASG. Don't use standalone instances. Okay, can you convert an ASG to standalone and vice versa? No, and there's no need, right? There's no need. Again, why would you want to do it? And even if you wanted to do it, there are ways of doing it. You can manually do it, right? So there's no need. You can add a standalone instances. You can add standalone instance or instances to an ASG, right? You can do that, so it becomes part of the auto scaling group, right? But you can't really convert vice versa. It's very simple to do it, right? All you have to do is, for example, if you want to convert an ASG to standalone, right? All you have to do is delete the ASG, right? Create standalone, right? It's just a few minutes that you need, right? And configure or register with the target group, right? So it's just a few minutes. So there's no need for anything special here, right? It can be done manually. All right. In case of desired capacity, when we terminated, rather than trying to restart, it starts a new server. Why did it not try to restart the same server before concluding it's not a good server? Because it doesn't know, right? How will it know, right? If it restarts again, it doesn't work, right? That's not good, right? So it doesn't know, right? It does not know anything about why the server is not functioning, right? And whether it does not know whether a restart will help, right? Also, a new server, also termination and a new server is the same, right? Has the same effect as a potential restart, right? So how is a restart better, right? There's no upside to doing a restart. Okay, so that's what it does. All right, because remember, not all problems get solved by a restart, right? It could be a hardware problem, right? That will not get restarted, fixed by a restart. So it doesn't know all that. All it knows is, the server is healthy or not. That's all it knows. It knows nothing about the cause of the problem. Okay, Chandra, can autoscaling be practiced in the free tier? Yeah, I think so. So look, in the free tier, you have 750 hours a month, right? So you can create a few servers as long as the total number of hours used is below 750 hours, right? And also the ELB is also covered to some extent under the free tier, right? So it should be fine, I think. Okay, it should be fine. Just read the fine print. Be careful about it. But also, one important point here, right, which I may have said before, right? Don't worry so much about the free tier, right? It's very important, because see, if you worry about the free tier all the time, right, then you'll not practice. You'll not be freely practicing. Okay, so don't worry about it. Even if there's a cost, right, it'll be, what, $1 or $2, $5, $10. That's it. Okay, so even if there's a cost, it'll be something like, it'll be say $5 a month. Right? That's it. Don't worry about it. Okay, you have to be disciplined. Make sure that you clean up. That's the most important thing. All right, NAT gateway you don't have to use. Okay, you don't have to use the NAT gateway. Don't use. You're right. NAT gateway is not under free tier. Okay, but don't use the NAT gateway. Right? Don't use the NAT gateway. You can use a regular default VPC, right? Don't use the NAT gateway for auto scaling. There's no need for that. All right. Next question. If we have scheduled downtime maintenance or deployments which require server restarts, then how does the ASG work as it brings up the new servers, which we don't want at this time? How do we take care of this situation? Yeah, so you have downtime and maintenance or deployments. So so you can suspend those actions, and you can make the desired capacity to 0, right? You can do lots of things. Okay, you can also right, you can also block things at the DNS level, right? So you can do lots of things. You can fail over to a static website while this is going on, right? So lots of options. Okay, lots of options, but mainly, you can suspend scaling activities, right? All these things can be done, right? You can set desired capacity, right? You can desired capacity to 0 if you want to stop your servers, right? So lots of options are available, right? You can also fail over. You can fail over to a maintenance site, right? At a DNS level. So lots of things you can do it, the way you do it normally, right? What do you do today? the same things you can do. What you do today when you have to do maintenance, right? That you have to look at and then see how to adapt that to the auto scaling group. All right, one more question here. So both the load balancer and ASG is taking care of health check. Is it not duplicated in two places? No duplication. So it causes a lot of confusion. Okay, that's why you may expect some questions on this in the AWS exam, right? It causes confusion, but it's not duplication because the ELB health check, right? The purpose of this is to decide to send traffic to the server or not. All right, that's what ELB does a health check for. The ASG health check, right? This is to decide if it should replace the server or not. They are two different things. Okay, they are two different things. Okay, so there's no duplication. Both have to do it, right? For their own purposes. All right. Okay, folks. So I think we are out of time. So let's stop here. If you have more questions, right? I know we spent a little less time on this, but we have module 10, right? So if you have more questions on this, you should practice this. We can then discuss it in module 10. All right. Balin, or I think one of you had asked me to explain this one, right? The load balancer. Let me know if you want that, right? If you want that, let me know. We can spend more time today, and I can explain it to you again, right? If required. Otherwise, we can discuss this more in module 10. All right. Now, a couple of more points here, right? Remember, we are now finishing module 6 here, right? So this is where we are. You should now start working on the course project, okay? Because the course project requires load balancing, auto scaling, RDS, and VPC. We've done all of that, okay? So please start working on the course project. We'll discuss any problems you have either via the support channel, all right, or in module 10, okay? Also, please try and do the quiz. See, test yourself, see if you've understood things or not. Again, we can use module 10 for further discussion, all right? Okay, and one more thing, please take some time and let me know via the feedback form, right, what you think about this course. Okay, that'll be really helpful. Maybe we can make some changes for the remainder of the course, and also, it'll help us do better with subsequent batches as well. All right, okay, folks. So that's it from me for today. I'll see you tomorrow.